In this video, we're going to work on a homework problem that deals with exponential functions. Let's take a look at an example, and this is similar to number 73 in section 5.2. A landscape company purchased a backhoe for $56,395. Every year, the price of the backhoe depreciates such that it retains 90% of its value from the previous year. So it has a 10% depreciation. So that retains 90%. So if we look at what happens in year 2, we're going to take that $56,395 and we multiply it by 0.9. And that gives us the value of the backhoe in the second year, about $50,756. To go for the year afterwards, in year 3, we're going to take that $50,756 and we multiply it by 0.9 again, and we get another value. Or my calculator, I'm just going to say times 0.9, and it's going to retain my previous answer. And that gives me $45,600 and, well, let's call it $80. We're multiplying by 0.9 every single time. If we want to build an equation as an exponential function, we can do this now. We can say that the value as a function of time is equal to my initial investment of $56,395 times 0.9 and then to the power of t. And so this is my exponential function. So now I can figure out what its value depreciates to in any given year. So if I say I want to know what it is after 10 years, that's going to be 56,395 and then 0.9 to the 10th power. And that's going to be a grand total of $19,664. So this is pretty easy to figure out what this depreciation is going to be given any year, as long as now we can establish our equation. So for any exponential function, remember, this part here represents your initial amount. This is your change per unit of time. A more difficult problem comes when how many years does it take to make the backhoe worth $30,000? And essentially what we're going to do is we want to take this equation here, this 56,395, 0.9 to the t is equal to $30,000. Now, one technique that we can use to solve this is by using logarithms, but that happens to be our next section, so we don't know how to use logarithms yet. So another technique that we can use is our graphing calculator, and we're going to type in both equations. I'm going to go to y equals, and type in my exponential equation of $56,395 times, I'm going to use x here, x to the power, I'm going to do 0.9 to the x power. Then I'm going to, under y sub 2, type in $30,000. And what I want to do is I want to graph both of these and figure out where these graphs intersect. The second one here is just going to be a horizontal line. So let's go and set up our window. Let's start with 0. Let's start with an x max of Well, I know in 10 years it goes to 19, so it's going to happen before then. So let's call it $9,000. My Y scale, my X scale is 1, that's good. My Y min, let's call it $0. My Y max was use 56,400. And then let's say our Y scale at every 10,000. Now when I graph this, I'm going to get two functions. The first one should be my exponential function. And this shows my amount that is depreciating over a unit of time. The red line here represents 30,000. So now to figure out where their intersection is, I do second calc, which is second calc here. I'm going to go to option number 5, which is intersect. Press enter. And it's asking me, do you want to select the first equation? And yes, we do. Second equation, yes, we do. The gas can be anywhere. And then it intersects at 5.99. So when t is equal to 6, that's when we have our answer. So I can check that. Say v of 6 is equal to 56,395 times 0.9 to the 6. Let's go ahead and check our answer. 56,395 times 0.9 to the 6. And that gives me, well, within $30 of 30,000.